Our gaze has been fixed skyward for millennia, captivated by the twinkling lights and vast expanse we call space. We build telescopes, launch probes, and chart constellations, believing we're uncovering its fundamental truths. Yet, what if the very picture we've constructed is incomplete, an elaborate illusion spun by our limited senses and nascent understanding? What if the universe, in its boundless complexity, has been subtly, profoundly, lying to us about its true nature, hiding secrets far grander and stranger than our boldest imaginations could ever conjure? Prepare to question everything you thought you knew. For centuries, we've conceived of space as a grand, echoing void, mostly empty save for the scattered celestial bodies. This immense vacuum seemed to be the ultimate quiet canvas upon which the cosmos painted its masterpieces. But this perception of emptiness, of nothingness, is perhaps one of the universe's most profound deceptions. Modern physics suggests that far from being empty, space is a seething cauldron of virtual particles, a quantum foam constantly bubbling into and out of existence, a vibrant, energetic fabric woven with invisible threads of power and potential. We observe galaxies, spinning at speeds that defy the gravitational pull of their visible matter. The only way our models hold true is if there's an invisible, undetectable substance exerting a massive gravitational influence. We call it dark matter, a cornerstone of modern cosmology, yet we cannot see it, touch it, or directly detect it. This unseen scaffolding, comprising an astonishing 85% of the matter in the universe, mocks our traditional understanding. Acting as a ghost in the cosmic machine, its presence felt only through its gravitational deception. If dark matter was a challenge, dark energy is an outright revolution. For decades, we expected the universe's expansion to slow due to gravity. Instead, observations revealed it's accelerating, stretching space itself apart at an ever-increasing rate. This mysterious repulsive force, dark energy, makes up nearly 70% of the universe's total energy density. It's the ultimate cosmic trickster, an invisible, intangible entity that is not only vast but actively pushing the cosmos towards an unknown future, defying every intuitive expectation of how gravity should behave. When we gaze at planets through telescopes or even examine images from probes, we often perceive solid, immutable surfaces, distinct geographical features, or swirling cloud tops. But this perception is a simplification. Many planets, particularly gas giants like Jupiter or Saturn, possess no true solid surface at all. Their atmospheres simply grow denser and hotter the deeper one descends, eventually transitioning into liquid metallic hydrogen under crushing pressures, a state of matter alien to our terrestrial experience, blurring the very definition of surface. For centuries, Earth was believed to be the sole possessor of vast liquid oceans. We thought water, the very essence of life, was a rare cosmic commodity. Yet, probe missions and new data reveal a startling truth. Subterranean oceans exist throughout our solar system, hidden beneath icy crusts on moons like Europa and Enceladus, and perhaps even within dwarf planets like Ceres. These vast, dark, internal seas, shielded from the harsh radiation of space, represent prime candidates for extraterrestrial life, completely altering our view of habitable zones. Our images of comets often show a bright head and a magnificent tail streaming behind, a celestial spectacle. We traditionally understood them as dirty snowballs, primarily ice mixed with dust. However, modern observations, particularly from missions that have flown through or landed on comets, unveil a more complex and surprising reality. They are often more like snowy dirt balls, rocky, porous structures with patches of ice, spewing jets of dust and gas in unexpected patterns. Their active surfaces and dynamic evolution challenge our neat, simplistic classifications. We perceive the sun as a stable, comforting ball of light and warmth, providing life to our world. Yet beneath its seemingly placid surface lies a turbulent, violent inferno. Its magnetic field lines twist and snap, unleashing solar flares and coronal mass ejections that can engulf planets, disrupt communications, and even strip away atmospheres. This dynamic, unpredictable behavior, largely invisible to the naked eye, reveals a far more complex and dangerous star than our gentle perceptions often convey, constantly shaping the space around it. Our intuitive image of a star is a perfectly spherical object, a giant ball of gas. While true for slower rotating stars, this isn't always the case. Very fast spinning stars, because of their immense centrifugal force, can become significantly oblate, squashed at the poles and bulging at the equator, resembling a candy more than a perfect sphere. Furthermore, binary star systems can feature stars gravitationally distorting each other into teardrop or egg shapes as they orbit, demonstrating that our simple geometric assumptions about celestial bodies are often quite limited. Cosmic microwave background, or CMB, is often presented as the definitive baby picture of the universe, uniform and isotropic proof of the Big Bang. And it is, in many ways. But the uniformity is what initially misled us. Only with greater precision did we detect tiny temperature fluctuations, the crucial seeds of all structure in the universe. More recently, some anomalies, like the cold spot or hemispheric power asymmetry, hint at deeper, perhaps even unexplainable patterns that challenge the simplest cosmological models. We often cite the age of the universe as approximately 13.8 billion years, a figure derived from the expansion rate and the cosmic microwave background. This number, however, is a model-dependent estimate. It relies on our understanding of fundamental constants, dark matter and dark energy, all of which still harbor great mysteries. Should future observations reveal significant deviations in these parameters, or if alternative cosmological models gain traction, our current truth about the universe's age could shift dramatically, revealing a different cosmic timeline. Our initial understanding often pictured galaxies as solitary, majestic spirals or ellipticals, isolated in the vastness of space. However, this is largely an illusion of scale. Galaxies are intricately woven into colossal cosmic webs, connected by filaments of gas and dark matter, gravitationally interacting, merging, and even devouring one another. Our own Milky Way is on a collision course with the Andromeda Galaxy, proving that these vast celestial cities are dynamic, interconnected entities, far from the isolated islands we once imagined. Quasars once confused astronomers, appearing as star-like objects emitting incredible amounts of energy, perplexing their true nature. The lie was in their seemingly stellar appearance, when in fact, they are the brightest and most distant active galactic nuclei, powered by supermassive black holes greedily consuming matter at the heart of young galaxies. Their extreme luminosity, outshining entire galaxies, taught us that the centers of most, if not all, galaxies harbor engines of immense power, completely redefining our understanding of galaxy evolution. The popular image of a black hole is a cosmic vacuum cleaner, mercilessly sucking in everything around them. While their gravitational pull is indeed immense, most black holes do not actively suck things in from vast distances. Objects must get very close, within their event horizon, to be truly lost. More importantly, newly discovered ultraluminous X-ray sources, or active galactic nuclei, defy the simple sucking narrative, showing black holes as engines of creation and destruction, shaping galaxies through their powerful jets and outflows, not just consuming. The illusion of silence in space. Space is often portrayed as silent, a perfect vacuum where sound cannot travel. And physically, that's true. There's no medium for sound waves, but this perceived silence is a simplistic lie of definition. Astronomical phenomena generate incredibly powerful vibrations. Gravitational waves from colliding black holes, radio waves from pulsars, plasma waves from solar winds. While not audible to human ears, these energetic emissions are a symphony of cosmic activity, which, when translated into audible frequencies, reveal a vibrant, noisy universe teeming with unseen movements and powerful forces. Albert Einstein proclaimed the speed of light in a vacuum as the cosmic speed limit, a fundamental constant. This is largely true, yet it's also a subtle deception. Light slows down when it passes through a medium, like water or glass, or even Earth's atmosphere. Furthermore, exotic theories like varying speed of light or modified gravity suggest that at the very early universe, the speed of light might have been different, offering potential solutions to cosmological puzzles. So while we consider it invariant, context and cutting-edge theory offer nuances. For centuries, humanity clung to a geocentric model, believing Earth was the center of creation. Even after Nicholas Copernicus and Galileo Galilei, we maintained a sense of unique centrality within the Milky Way. But the truth is, we are not special. Our solar system is just one of billions in our galaxy. which is itself one of billions in the observable universe. The lie of our perceived importance has been systematically stripped away, revealing our cosmic address as utterly unremarkable, making us confront the humbling reality of our tiny, insignificant sliver of cosmic real estate. We have always looked to constellations as immutable patterns in the night sky, guiding our navigation and inspiring mythology. Orion, the Big Dipper, Cassiopeia. They seem eternal, but this is an illusion, a lie of short-term perception. Over vast stretches of cosmic time, stars move. They drift, orbit the galactic center, and their relative positions slowly but surely change. The constellations our distant ancestors saw are slightly different from ours, and those of future generations will be unrecognizable, revealing the dynamic, ever-shifting nature of our celestial tapestry. Modern cosmology largely agrees that the universe, on a large scale, appears to be geometrically flat, meaning Euclidean geometry applies, and parallel lines will never meet. This flatness is a crucial finding, supporting the inflationary theory. However, this doesn't mean it's physically two-dimensional or literally flat like a pancake. It refers to its overall curvature. Furthermore, the possibility, however small, remains that with more precise measurements, we might discover a subtle positive or negative curvature, changing our understanding of its ultimate fate and scale. While our observable universe appears flat, we still don't know the true global topology of the entire universe. It could be infinite and flat, or it could be finite but unbounded, like the surface of a globe, but in higher dimensions. It could be donut-shaped, a torus, or something even more complex. The lie is our assumption of understanding its ultimate form beyond our limited observable horizon. The cosmic landscape we inhabit might be infinitely repeating, or closed upon itself in ways we cannot yet perceive or mathematically describe. Descriptions of the Big Bang often depict a point-like explosion, the absolute beginning of everything space-time. But this is an oversimplification, a lie of common language. The theory only describes the evolution of the universe from an extremely hot, dense state, but it doesn't explain what existed before that state, or how that state came to be. It's a description of expansion, not creation from nothingness. The true beginning remains one of the universe's most profound unanswered questions, pushing the boundaries of our current physics. We say the universe is expanding, and pictures often show galaxies flying away from a central point. This visual is misleading. The universe isn't expanding into pre-existing space. Rather, space itself is being created and stretched between objects. Imagine baking a raisin bread. The raisins aren't moving through the dough. The dough itself is rising, carrying the raisins apart. This fundamental concept, that space itself is a dynamic entity, constantly stretching, is a profound truth often obscured by simpler analogies, leading to a misperception of cosmic mechanics. Our everyday experience is of time flowing uniformly, second by second, everywhere. But Albert Einstein's relativity shattered this lie. Time is relative. It slows down near massive objects and at high speeds. An astronaut traveling close to the speed of light would age slower than someone on Earth, and time passes demonstrably slower for objects closer to a black hole. This means there's no universal ticking clock for the cosmos, forcing us to abandon our intuitive, comforting notion of absolute, unwavering time. When we talk about the observable universe, we mean the portion from which light has and could have reached us since the Big Bang. But this horizon, about 46 billion light-years in radius, isn't the edge of the universe. It's merely the limit of our sight, given the age of the cosmos and the speed of light. Beyond this boundary, there's more universe, perhaps infinitely more, forever hidden from our direct observation. The lie is the implication that our visible sphere encompasses everything, when it's just a tiny, limited bubble within a potentially boundless reality. The public imagination often gravitates towards Earth-like exoplanets, envisioning distant worlds perfectly suited for life as we know it. While such worlds might exist, the overwhelming majority of discovered exoplanets are vastly different. Super-Earths with scalding atmospheres, gas giants orbiting precariously close to their stars, rogue planets drifting through interstellar space without a sun. These are the norm. The lie is our anthropocentric bias, projecting our single, unique planetary experience onto the infinite variety of worlds the galaxy truly holds. For decades, the moon was believed to be utterly devoid of water, a barren, arid wasteland. This lie influenced our understanding of lunar geology and potential future missions. However, multiple missions from the Clementine to Lunar Prospector and LCROSS have definitively confirmed the presence of significant amounts of water ice, particularly in permanently shadowed craters at the poles. This revelation changes everything, suggesting future lunar bases could potentially extract water for life support or rocket fuel, making lunar colonization far more feasible. Science fiction often portrays the asteroid belt as a perilous, densely packed obstacle course, requiring expert piloting to navigate. This dramatic depiction is a fascinating lie. In reality, the asteroid belt is so vast that the average distance between significant objects is hundreds of thousands, even millions of miles. Space probes have traversed it with minimal risk of collision. This dispels the cinematic fantasy, revealing a much emptier and safer region than commonly imagined, making our solar system far more navigable than depicted. We visualize the Milky Way as a grand, magnificent spiral, about 100,000 light-years across. This is true for its luminous stellar disk, but the lie is in overlooking its true, immense scale. The Milky Way's galactic halo, an enormous, spherical distribution of dark matter and sparse globular clusters, extends far beyond the visible disk, possibly up to 1 million light-years in diameter. Our visible galaxy is merely the tip of a cosmic iceberg, dwarfed by its unseen gravitational sphere of influence, profoundly larger than we perceive. Science fiction stories routinely feature starships zipping across interstellar distances in days or weeks, making galactic travel seem easily achievable. This common narrative is a profound lie when confronted with the vastness of space and the limitations of physics. Even at incredibly high, near-light speeds, traversing the distance to the nearest star, Proxima Centauri, would take years, possibly decades. Traveling to other galaxies is currently beyond the realm of practical imagination, highlighting the immense barriers to true cosmic voyaging. The universe isn't a single synchronized clock. Due to gravitational time dilation, clocks run slower in stronger gravitational fields. This means your phone's GPS, relying on satellites and weaker gravity, has to account for them running slightly faster than clocks on the ground. If they didn't, your GPS would be inaccurate by miles. This practical example reveals that the lie of a single universal time is routinely corrected for, demonstrating that duration and simultaneity are not fixed, but relative to position in the universe's gravitational landscape. While space is a near-perfect vacuum, it's not entirely empty. It contains trace amounts of gas atoms, dust particles, cosmic rays, photons from the cosmic microwave background, and neutrinos. Even gravitational waves permeate it. These seemingly minuscule components contribute to a complex, albeit extremely diffuse, interstellar medium that influences light, shapes stellar nurseries, and even affects the propagation of cosmic rays. The lie of absolute emptiness crumbles under closer inspection, revealing a tenuous but active cosmic broth. The habitable zone, or Goldilocks zone, defines the region around a star where liquid water might exist on a planet's surface. For a long time, this was the primary criteria for habitability. However, this is a restrictive lie. Moons with subsurface oceans, like Europa or Enceladus, exist outside their star's habitable zone, yet could harbor life sustained by hydrothermal vents. Furthermore, some scientists propose rogue planets with thick atmospheres could generate internal heat and support life, even without a star, vastly expanding our notions of where life could emerge. Our measurements of cosmic distances, crucial for understanding the universe's scale and expansion, rely on a cosmic distance ladder, a series of overlapping techniques. Each rung calibrates the next, from parallax to Cepheid variables to type Ia supernovae. The lie isn't in their utility, but their inherent cumulative uncertainty. Errors at one level propagate to the next, meaning our most precise distances to the farthest galaxies might have small but significant margins of error, subtly shifting our understanding of the universe's true scale and expansion rate. When we look at stunning images from Hubble or James Webb, we see distant galaxies in exquisite detail. It creates the impression of unimpeded vision. However, light from these distant objects travels for billions of years, encountering countless obstacles. Interstellar dust, gas clouds, and even the gravitational lensing effects of hidden matter. These factors can dim, redden, distort, and even multiply images of distant objects. The lie is the apparent clarity. The universe places many veils and funnels between us and the true, unadulterated light from beyond. Nebulae are often portrayed as glowing, vibrant clouds of gas and dust, universally illuminated wonders. While stunning, this is a generalization, a visual lie. Many nebulae are dark molecular clouds, completely opaque, absorbing all light, serving as stellar nurseries hidden in plain sight. Others are reflection nebulae, only visible because they scatter light from nearby stars, not because they emit their own. Each has unique characteristics, reminding us that cosmic beauty often hides complex, varied physical processes beyond simple luminescence. We tend to think of the sun as a typical star, a perfect example of stellar normalcy. The lie is that it's actually somewhat overluminous and larger than the most common stars in the galaxy, which are red dwarfs. Red dwarfs are the undisputed majority, living for trillions of years compared to our sun's mere 10 billion. This realization shifts our perspective on what a standard star is, making our solar system a less common planetary arrangement than we might assume, impacting our search for life. When we look at images of galaxies, stars can appear somewhat evenly distributed within their arms or throughout stellar populations. However, this is a simplification. Stars are born in clusters, within dense molecular clouds forming vast stellar nurseries. Over time, these clusters disperse, but the initial distribution is highly clumpy. The lie is the perceived uniformity. The universe is profoundly structured, with stars congregating in gravitationally bound groups before spreading out, reflecting a more dynamic and less chaotic formation process than often assumed. We think of weather pertaining to Earth's atmosphere. The lie is our limited definition, ignoring the powerful space weather that constantly bombards our planet. Solar flares, coronal mass ejections, and high-energy particles from the sun create disturbances in Earth's magnetosphere, disrupting communications, GPS, power grids, and exposing astronauts to radiation. This unseen, dynamic environment, far from being peaceful, is a constant, energetic torrent that reminds us of the sun's immense power and our planet's vulnerability. We perceive space as a black void, punctured by stars. This visual lie is due to the limits of our perception and the vast distances. If your eyes were sensitive enough and gathered light for long enough, the universe would not be black. It would be a vibrant, creamy beige. Scientists have even coined a term, cosmic latte, for this average color of light emitted by all the stars and galaxies combined over cosmic history. The universe, in its totality, is a faint, glowing café au lait, far from the stark darkness we typically imagine. While the general consensus is that the universe's expansion is accelerating, studies are beginning to suggest this acceleration might not be uniform in all directions. Some research hints at a cosmic dipole, where the universe seems to expand faster in one direction than another, a finding that would challenge our cornerstone assumption of cosmological isotropy, that the universe looks the same in all directions on large scales. If true, it would be a major lie uncovered, forcing a rethink of our fundamental cosmological models. Albert Einstein's general relativity perfectly describes gravity on large cosmic scales and within our solar system, yet it encounters problems on quantum scales and struggles to integrate with quantum mechanics. This signals a gaping hole, a hidden lie in our current understanding. Theories like quantum gravity, string theory, and loop quantum gravity attempt to reconcile these discrepancies, suggesting gravity is far more complex than a mere curvature of spacetime, involving gravitons, extra dimensions, or entirely new fundamental forces we've yet to grasp. Our solar system appears tidy and stable, planets orbiting in perfect ellipses for billions of years. This apparent tranquility is a long-term lie. While short-term stable over immense timescales, planetary orbits are chaotic and unpredictable. Gravitational interactions between planets, especially gas giants, can cause subtle nudges that, over millions or billions of years, could lead to orbital instabilities, collisions, or even ejections from the solar system. Our current orbital harmony is a momentary pause in a cosmic dance of potential disarray. The Goldilocks principle applied to Earth, that everything is just right for life, is a simplistic lie. Life on Earth adapted to its conditions, not the other way around. Extremophiles thrive in environments we once thought utterly sterile. Deep-sea vents, highly acidic pools, radioactive waste. This shows that life is far more resilient and adaptable than we initially believed, vastly expanding the range of potential conditions where life could arise elsewhere in the universe, going beyond our narrow Earth-centric assumptions. We often envision galaxies as homogeneous mixes of stars, gas, and dust. But this is a lie of oversimplification. Galaxies have distinct regions: a bulging central supermassive black hole, a dense stellar disk, sprawling spiral arms, and a vast, diffuse halo. Each region has different stellar populations, chemical compositions, and dynamics. Some galaxies even contain dark galaxies, composed almost entirely of dark matter with very few stars, revealing a much more stratified and diverse internal structure than generally depicted. We generally understand stars are born from collapsing gas clouds. This picture, however, omits crucial complexities, presenting a simplified lie. Star formation is incredibly inefficient, with only a small fraction of a cloud's mass-forming stars. It's also a violent process, with powerful outflows and jets from nascent stars preventing further collapse and often dispersing much of the surrounding material. This feedback loop shapes stellar nurseries and galactic evolution in ways far more intricate than a simple gravitational collapse suggests. While the Big Bang model successfully describes the universe's evolution since a tiny fraction of a second after its apparent beginning, it doesn't explain the initial conditions that set it all in motion. Why was the universe so uniform on large scales but with tiny, crucial fluctuations? Why did it begin with such low entropy? These fundamental questions remain unanswered, pointing to a profound lie of omission in our current cosmological framework. The very genesis of the universe's existence and properties remains shrouded in deep mystery, challenging our understanding. We categorize the universe's fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. This clear distinction is a lie of our current understanding. At incredibly high energies, such as those present in the early universe, these forces are believed to unify, behaving as aspects of a single, primordial force. Grand unified theories and string theory attempt to describe this ultimate unity. Our perceived separate forces are merely different manifestations of a deeper, underlying cosmic reality that existed at the universe's genesis. For years, the Hubble constant, which describes the universe's current expansion rate, seemed relatively settled. However, recent, more precise measurements from different methods are yielding conflicting values, creating what's known as the Hubble tension. Measurements from the early universe cosmic microwave background disagree with those from nearby supernovae. This discrepancy signals a potential lie in our cosmological model, suggesting either unknown physics, systematic errors, or an incomplete understanding of the universe's fundamental expansion dynamics. The idea of an edge to the universe is an intuitive but misleading lie. If the universe is infinite, it has no edge. If it's finite but unbounded like the surface of a sphere, but in more dimensions, it also has no edge you could ever reach. The concept of an edge implies something outside the universe, which contradicts our definition of the universe as everything that exists. Our perception of boundaries is often a projection of finite earthly experience onto an infinitely complex cosmic reality. While purely speculative and often relegated to science fiction, some theories propose the possibility of macroscopic life forms adapted to the vacuum of space, feeding on stellar energy, cosmic dust, or even dark matter. While no evidence exists, this thought experiment challenges the deeply ingrained lie that life must always be planetary. If such forms existed, they would redefine biology, ecology, and our search for life, forcing us to consider entirely new paradigms for biological existence beyond our earthbound definition. For centuries, our definition of planet was broad. Then in 2006, Pluto's reclassification caused uproar. This controversy revealed the lie of a clear, immutable definition. The International Astronomical Union's criteria for a planet, orbiting a star, being roughly spherical, and having cleared its neighborhood, are specific to our solar system's inner dynamics, and don't easily apply to the diversity of exoplanets like rogue planets or super-Earths that reside far from their stellar primaries or are shaped differently. We imagine the vast voids between galaxies as truly empty, a quiescent cosmic desert. This is a subtle lie. Far from being empty, these intergalactic spaces are filled with an incredibly tenuous but pervasive medium of hot, ionized gas, known as the warm-hot intergalactic medium, or WIM. It's difficult to detect, but its existence accounts for a significant portion of the universe's missing baryons, the ordinary matter not found in stars or galaxies, revealing a cosmic web far more intricate and filled than once thought. When we picture a black hole's accretion disk, we think of a swirling vortex right around the black hole. The lie is scale. For supermassive black holes, these disks can span light years, dwarfing entire solar systems. The friction within these vast disks superheats gas to millions of degrees, generating immense radiation that makes quasars detectable across the cosmos. Their sheer size and energetic output are often vastly underestimated, making them fundamental, powerful engines shaping galactic evolution on immense scales. We use the terms dark matter and dark energy because they are invisible, non-interacting with light. But the lie is in what dark truly implies. It means we have no idea what they fundamentally are. They are placeholders for unknown physics, profound mysteries that demand new theories, new particles, or even new dimensions to explain their existence. Until we unravel their true nature, dark reminds us of the limits of our current particle physics and cosmological models, representing the vast unknowns that frame our universe. Our current view of the cosmos is one teeming with billions of stars and countless galaxies. It's easy to assume this was always the case, but the lie is the assumption of stellar ubiquity. For hundreds of millions of years after the Big Bang, the universe was a dark, opaque plasma, then a cold, neutral gas. There were no stars. The first stars, massive and short-lived, formed perhaps 100 to 200 million years after the Big Bang, reionizing the universe and paving the way for the cosmic structures we see today. That initial period was one of profound darkness. We often envision the universe's expansion as a smooth, continuous stretching of space. This is a large-scale lie. On local scales, gravity dominates. Galaxies clump together into clusters, and these clusters fall towards even larger superclusters, forming nodes in the cosmic web. Our own Milky Way is being gravitationally pulled toward the Great Attractor, a colossal overdensity of matter. So while the universe expands overall, locally, gravitation tugs and pulls, creating a lumpy, non-uniform distribution of matter. If you describe your cosmic address today, Earth, Solar System, Milky Way, Local Group, Virgo Supercluster, that address is only temporarily correct. Our galaxy is hurtling towards the Andromeda Galaxy, eventually to merge. The local group is being pulled towards the massive Laniakea supercluster. Everything is in motion, constantly changing its relative position. The lie is the static nature of our cosmic place. We are dynamic inhabitants of an ever-shifting, gravitationally connected cosmic landscape, constantly on the move. Gamma-ray bursts, or GRBs, are the most powerful explosions in the universe since the Big Bang, releasing more energy in seconds than the sun will in its entire lifetime. Their true origin was a decades-long mystery, giving rise to many speculative theories. We now know they come from the collapse of massive stars into black holes, or the merger of neutron stars. This revelation unveiled the lie of their elusive nature, revealing incredibly energetic astrophysical processes that challenge our understanding of stellar death and the limits of energy output. When we see pictures of galaxies, they appear densely packed with stars. This is often a visual lie of artistic compression. Even within the spiral arms and central bulges of galaxies, the amount of truly empty space between stars is astronomical. If the Sun were a grain of sand, the nearest star, Proxima Centauri, would be miles away. Collisions between stars are incredibly rare. The universe, even in its densest regions, remains overwhelmingly vacuum, emphasizing the vast, pervasive emptiness beyond celestial bodies themselves. Our simplistic understanding often lumps stellar death into a few categories: white dwarfs, neutron stars, or black holes. But the lie is the variety. Some stars pulsate violently before becoming white dwarfs. Others explode as supernovae, leaving behind intricate nebulae. Some neutron stars rapidly rotate as pulsars, while others merge to create gravitational waves. The cosmic graveyard is far more diverse and dynamic than a simple end state, offering a myriad of fascinating, violent, and spectacular conclusions to a star's life cycle. We cherish visible light as our primary window to the cosmos. But this reliance is a lie. The universe is largely opaque in many wavelengths. Interstellar dust blocks visible and ultraviolet light. Galactic centers are obscured by gas, and the early universe was a thick cosmic fog. Only by using radio waves, infrared, X-rays, and gamma rays can we peer through these obscurations, revealing hidden structures, nascent stars, and distant galaxies that are completely invisible to our optical telescopes. Our full cosmic picture relies on a multispectral sensory array. When we draw diagrams of the solar system, the sun is invariably at the exact center. This is a common, convenient lie. While massively dominant, the sun is not perfectly stationary. All the planets tug on it, causing it to wobble slightly around the true center of mass of the solar system, which lies just outside or slightly within the sun itself depending on the planetary alignment. This subtle but constant motion reveals that even our dominant star is part of a complex gravitational dance, not a static anchor. Saturn's rings are often depicted as solid, majestic structures. This is a beautiful lie. In reality, they are not solid at all, but comprised of billions of individual ice and rock particles, ranging from micron-sized dust grains to house-sized boulders, all orbiting independently. The intricate patterns, gaps, and spokes are formed by gravitational interactions with Saturn's moons, creating a dynamic, ever-changing system, far more complex and active than a simple, static planetary adornment. We have conceptualized the cosmos as a vast, cosmic web of galaxy filaments and voids, a structure defined by gravity. While observed, the precise formation mechanisms and evolution of this largest-scale structure are still areas of intense research. How exactly do dark matter halos assemble and merge to form these superclusters and voids? The lie is the implication of full comprehension. The cosmic web's intricate dance of gravity and dark energy on the grandest scales remains a profound puzzle, pushing the limits of our simulations. While it might appear as if space within or around a quasar's central supermassive black hole is empty, it's anything but. The lie is our perception of emptiness in extreme environments. Surrounding the black hole is an intensely hot, super-dense accretion disk, then a broad, dusty torus, and then powerful, relativistic jets of plasma extending for millions of light-years. These regions are filled with matter, radiation, and magnetic fields interacting violently, making them some of the most energetically active and complex environments in the entire universe. We rely on fundamental constants like the speed of light, the gravitational constant, or the fine structure constant to underpin our physics. The lie is the implicit assumption of their absolute unwavering constancy across all of cosmic time and space. While strong evidence suggests they are indeed constant, some fringe theories or subtle observational anomalies hint that they might have varied slightly in the very early universe or across vast cosmic distances. If proven, this would fundamentally rewrite our understanding of physical laws. The event horizon of a black hole is depicted as a distinct, solid surface, a point of no return. Yet this is a profound lie of visualization. It's not a physical surface. It's a boundary in space-time, a mathematical point beyond which nothing, not even light, can escape the black hole's gravity. An infalling observer wouldn't feel anything specific crossing it until they were stretched and torn by tidal forces closer to the singularity. It's a region of extreme curvature, not a tangible barrier, making it far more mysterious than its simplified image. We assume the vacuum of space is universally cold, near absolute zero. This is a common lie. While the cosmic microwave background is indeed extremely cold, local environments vary wildly. Closer to stars, temperatures can reach thousands of degrees. Within accretion disks of black holes, matter is heated to millions of degrees, radiating X-rays. Even empty space between galaxies can be filled with tenuous gas heated to hundreds of thousands of degrees. The universe experiences extreme temperature gradients, challenging the notion of uniform frigidness. The fact that our universe appears flat on large scales is a peculiar lie in itself, given how unlikely it is for this precise geometry to arise naturally. It implies an extremely fine-tuned initial condition. The leading explanation, cosmic inflation, posits a brief exponential expansion in the early universe, which flattened it out like blowing up a balloon. While widely accepted, direct evidence for inflation remains elusive, making our understanding of this fundamental cosmic property an ongoing debate. We often frame history as a linear progression. Ancient people were ignorant, then modern science emerged. This perpetuates the lie that ancient civilizations had little understanding of cosmology. Cultures like the Mayans, Egyptians, and Babylonians developed incredibly precise astronomical observations and calendars, tracking planetary motions, predicting eclipses, and often incorporating sophisticated cosmic cycles into their worldview, demonstrating a profound, intricate understanding of celestial mechanics far beyond simple stargazing. The universe looks profoundly different depending on the scale you're observing. On human scales, it's lumpy with planets and stars. On galactic scales, it's structured by spiral arms and central bulges. On supercluster scales, it forms the cosmic web filaments. But above a certain scale, the universe appears remarkably uniform and isotropic. The lie is our tendency to apply observations from one scale to another, without recognizing the fundamental shifts in applicable physics and observed phenomena, leading to an incomplete understanding of its true hierarchy. Although there's a limit to what we can see now, the observable universe isn't static. It's constantly expanding as more light from increasingly distant objects has had time to reach us. Every second, new photons arrive from regions of space that were previously beyond our cosmic horizon. The lie is the static nature implied by the term observable universe. It's a dynamic, ever-enlarging sphere, providing us with glimpses of previously inaccessible pasts and more distant reaches of the cosmos. Scientific models predict several fates for the universe: the Big Freeze, Big Crunch, or Big Rip. Our understanding of dark energy's precise nature and density dictates which scenario prevails. The lie is the impression of a settled future. While the Big Freeze or heat death is currently favored, subtle changes in our measurements of dark energy or new theoretical insights could swing the pendulum, keeping the ultimate destiny of all existence a profound and intriguing cosmic mystery, far from a foregone conclusion. Our everyday intuition tells us gravity is a force that pulls objects towards each other. This is a practical lie. Albert Einstein revealed gravity isn't a force at all, but a consequence of mass and energy warping the fabric of space-time itself. Objects aren't pulled. They simply follow the curves in the space-time created by massive objects. This fundamental shift from force to geometry fundamentally redefines our physical reality, revealing a universe where space and time are dynamic, shapeable entities. The cosmic web creates immense, galaxy-sparse regions known as voids, often considered the emptiest places in the universe. While much less dense, the lie is that they are utterly desolate. Voids still contain extremely sparse filamentary structures, sometimes faint, isolated galaxies, and pervasive dark matter and dark energy. They are not absolute vacuums, but rather underdense regions, vast cosmic stretches where gravity's influence is weakest, revealing a universe that is structured even in its most barren stretches. We learn about planets orbiting the sun, but the entire solar system is itself moving, and not in a simple orbit. The sun and its planets are orbiting the center of the Milky Way, bobbing up and down through the galactic plane like a carousel horse. Our solar system is also moving relative to the local standard of rest and the cosmic microwave background dipole. The lie is the simplistic, flat orbital plane depiction. Our true motion through space is a complex, multidimensional spiral, constantly changing its orientation and trajectory. The standard model of particle physics details a specific set of fundamental particles, but this is potentially a lie of completeness. Discoveries like the Higgs boson confirmed one piece, but observations like dark matter and dark energy imply particles or forces beyond the standard model. Neutrinos themselves have properties not fully explained. The particle zoo could be much larger, with undiscovered particles or even supersymmetric partners waiting to be found, suggesting our current understanding is still profoundly incomplete. The cosmic redshift, where light from distant galaxies appears stretched to longer, redder wavelengths, is our primary evidence for the universe's expansion. However, the lie is the intuitive analogy to a Doppler effect, where galaxies are simply flying through space away from us. Instead, redshift is primarily due to the stretching of space itself between the source and observer, literally stretching the light waves as they travel. This distinction is crucial for understanding the fabric of space-time, rather than mere kinematics. We experience events as singular moments in time, but relativity unveils a deeper lie. What is simultaneous for one observer is not simultaneous for another, especially at high speeds or across vast cosmic distances. There is no universal now. This means our perception of past, present, and future is relative, not absolute, challenging our most fundamental understanding of linear time and the very nature of existence. Events unfold differently depending on your cosmic vantage point. While we have many theories, the precise mechanisms by which life originated from non-living matter on Earth, a process called abiogenesis, remain one of science's profound unsolved mysteries. Was it in primordial soups, deep-sea vents, or perhaps even brought from space through panspermia? The lie is the impression of a clear, settled scientific narrative. The leap from chemistry to biology is incredibly complex, highlighting that even our own origins hold major scientific uncertainties. The moon appears much larger when it's near the horizon than when it's high in the sky, a well-known phenomenon called the moon illusion. While largely explained by how our brain processes visual cues against a terrestrial backdrop, it highlights a broader lie of perception in astronomy. What we see is not always what is. Our brains actively interpret and contextualize information, meaning seemingly obvious visual facts about celestial objects can be mere tricks of perspective, reminding us to rely on instruments over intuition alone. We think of atoms as tiny, solid balls. But this is a profound lie of our intuition and simplified models. Atoms are mostly empty space, with a tiny nucleus surrounded by an electron cloud. Yet, this empty space is actually seething with quantum fields, virtual particles, and immense forces. It's a vibrating, energetic void. The solidity of matter arises from these fields, not from packed particles, revealing that even at the most fundamental levels, the universe is vastly more dynamic and less empty than it seems. When we say the sun is burning, it conjures an image of chemical combustion, like wood burning in a fireplace. This is a crucial lie. The sun, like all stars, generates energy through nuclear fusion, converting hydrogen into helium in its core. This process releases immense energy according to E=mc², not through chemical reactions. The duration, intensity, and fundamental physics of this process are vastly different from terrestrial burning, revealing the true nature of stellar power generation. Beyond Neptune lies the Kuiper Belt, a vast region of icy bodies home to Pluto and other dwarf planets. The lie is that we have a complete picture of it. We've only charted a fraction of its objects. The proposed Planet 9, a large, unseen planet, is hypothesized to explain the unusual orbits of distant Kuiper Belt objects, suggesting our understanding of the outer solar system's architecture is still incomplete. The realm beyond Neptune remains largely an uncharted, mysterious wilderness. While astronomers rely on the cosmological principle that the universe is homogeneous and isotropic on very large scales, tantalizing evidence suggests subtle deviations. The Hubble tension, mentioned earlier, is one example. Another is the axis of evil, a slight alignment of certain features in the cosmic microwave background, which some interpret as a preferred direction. While likely statistical flukes, these hints challenge the lie of absolute uniformity, suggesting deeper, unseen anisotropies in the early universe. When we look at distant galaxies through a telescope, we are seeing them as they were billions of years ago. Light takes time to travel. While this is broadly understood, the lie is the implicit assumption that the past snapshot we receive is the only past for that object. Gravitational lensing can create multiple images of the same distant galaxy, each having traveled a slightly different path and therefore a different travel time, showing us the same object at slightly different past moments, revealing a fragmented view of cosmic history. The idea that space is just uniformly cold is a lie that ignores its dynamic thermal properties. Objects in space heat up intensely when exposed to sunlight and radiate that heat away into the vacuum. Satellites and spacecraft must constantly be managed with complex thermal systems to stop them from freezing or overheating as they rotate from light to shadow. This active thermal balance, rather than a passive cold, reveals a far more challenging environment for engineering and life support in space. The poetic phrase, "we are stardust," is profoundly true. The heavy elements that make up our bodies, carbon, oxygen, iron, were forged in the hearts of long-dead stars and dispersed by supernovae. But the lie is the implication of a direct connection to all stars. The elements in our bodies came from stars that lived and died before our sun was born. Our sun is a second-generation star, formed from the enriched remnants of previous stellar cycles, revealing our truly ancient, recycled cosmic lineage. Earth's magnetic field, our shield against the solar wind and cosmic radiation, might seem like a stable, unwavering barrier. But this is a lie. It is dynamic and ever-changing. The magnetic poles are constantly drifting, and the field experiences flips every few 100,000 years, reversing its polarity. Furthermore, solar storms can temporarily weaken or distort it. This constant fluctuation and potential for reversal highlight a complex, dynamic planetary defense system, not a static, impenetrable shield. We traditionally draw the solar system ending at Pluto or the Kuiper Belt. But this is a profound lie of definition. The outer reach of the sun's gravitational influence extends far beyond, into the Oort cloud, a vast, spherical shell of icy objects thought to be the source of long-period comets. This region, extending perhaps a light-year or more, defines the true gravitational boundary of our solar system, making it immensely larger and more diffuse than our planetary maps typically illustrate. We often envision the early universe after the Big Bang as a uniform, featureless plasma. While largely homogeneous, this is a lie of scale. Tiny quantum fluctuations from the inflationary epoch were stretched to cosmic scales, imprinted as subtle temperature variations in the cosmic microwave background. These minute density differences were the crucial seeds of all future structure: galaxies, clusters, and the cosmic web. The universe began not as a perfect blank slate, but with subtle, crucial predispositions. For decades, we considered liquid water a rare, precious commodity in the universe, making Earth seem unique. This was an anthropocentric lie. Not only are there subsurface oceans in our solar system, but water in various forms, ice, vapor, even exotic high-pressure ice phases, has been detected abundantly in nebulae, comets, on Mars, in exoplanet atmospheres, and even in interstellar clouds. Water, the building block of life, is far more common in the cosmos than we ever dared to imagine. The solar wind, a stream of charged particles constantly emanating from the sun, sounds benign. But this is a misleading lie. It's a powerful supersonic flow of plasma that sculpts planetary magnetospheres, creates auroras, and defines the heliosphere, our solar system's protective bubble against interstellar radiation. Its dynamic pressure and embedded magnetic fields constantly interact with everything in its path, proving it is a significant, pervasive, and influential force in shaping the local cosmos. While the early universe experienced prolific star formation, the lie is the idea that this process has ceased or significantly slowed globally. Galaxies, including our own Milky Way, continue to form new stars and planets in their cold, dense molecular clouds. Star formation is an ongoing, cyclical process fueled by cosmic gas and dust, constantly invigorating galaxies with new generations of luminous bodies, reminding us that the universe is still alive and evolving. Our instinct from our Earth-centric perspective is to imagine a literal center to the universe where the Big Bang occurred. This is a fundamental lie. The Big Bang wasn't an explosion in space, but the expansion of space itself. Every point in the universe can be considered the center of its own observable universe, and simultaneously, there is no spatial center at all. This non-centeredness profoundly challenges our intuitive grasp of origin and location on a cosmic scale. Electromagnetism, familiar on Earth, is profoundly powerful on cosmic scales. Yet, the lie is our complete understanding. While gravity usually dominates, magnetic fields permeate galaxies, influence star formation, and are crucial to phenomena like black hole jets. How these fields are generated and maintained on galactic scales, the dynamo problem, remains a complex puzzle. Plasma physics, often more influential than gravity in diffuse cosmic environments, adds layers of complexity, showing incomplete understanding. We draw a clear line for Earth's atmosphere, like the Kármán line at 100 kilometers. But this is a convenient, albeit useful, lie. Earth's atmosphere doesn't abruptly end, it gradually thins out, merging imperceptibly with the vacuum of space. The exosphere, the outermost layer, extends for thousands of kilometers, with individual atoms slowly escaping into interplanetary space. This gradual dissipation highlights that the boundary between our planet and the cosmos is a fluid, continuous transition, not a sharp cutoff. We typically define planets as roughly spherical. But the lie is the implication that all significant celestial bodies conform to this. Smaller asteroids and comets are often highly irregularly shaped, resembling potatoes or rubble piles due to their weaker gravity not being strong enough to pull them into a sphere. Even larger bodies, if they spin fast enough, like the dwarf planet Haumea, can be ellipsoidal. This diversity challenges our simple categories and reveals the vast morphological spectrum of cosmic objects. Even within our relatively full solar system, the amount of truly empty space is staggering. From the Kuiper Belt to the inner planets, the distances are immense, and objects are infinitesimally small in comparison. If the solar system were the size of a football field, the distance between Jupiter and Saturn would still be several yards. The lie is our compressed mental models. The local cosmos is overwhelmingly vast and empty even in our cosmic backyard. We experience the universe as silent. But if you consider beyond human perception, the universe is a symphony. Gravitational waves are ripples in space-time. Radio waves carry signals from pulsars in distant galaxies. Plasma waves propagate through solar flares. It's a universe vibrating with energy, information, and unseen forces. The lie is our biological limitation. The cosmos is profoundly noisy and active, a grand orchestra of energy that we often only hear when translated by incredibly sensitive instruments. We often hear about a galaxy's overall age, but this is a lie of averaging. Galaxies, especially spiral ones, have distinct stellar populations of varying ages. The central bulge often contains older, redder stars, while the spiral arms are active star-forming regions with young, blue, massive stars. Elliptical galaxies tend to be dominated by older stars, while irregulars show chaotic bursts of new star formation. The universe's cosmic clock doesn't tick uniformly across its stellar cities. Pulsars are celestial objects that emit incredibly regular pulses of radiation, earning them the nickname cosmic clocks. While remarkably precise, even they reveal a subtle lie. Pulsars are not perfectly stable. They experience glitches, sudden, tiny speed-ups or slowdowns, which are thought to be caused by internal seismic activity in their neutron star crusts. This demonstrates that even the most reliable cosmic timekeepers have their quirks, proving that absolute unwavering regularity is a rare cosmic commodity. The accelerating expansion of the universe attributed to dark energy poses one of the most profound mysteries. The lie is the assumption that dark energy is merely a cosmological constant. Many physicists hypothesize it could be a dynamic, evolving field, or that the acceleration could signal a breakdown of general relativity on vast scales, requiring a modified gravity theory. This cosmic acceleration pushes us to consider entirely new physics, challenging our fundamental understanding of the universe's mechanics. When we see light from a distant star, we assume it travels in a perfectly straight line from source to eye. This Euclidean intuition is a lie. Light always follows the curvature of space-time, which means it rarely, if ever, travels in a perfectly straight line due to the presence of mass and energy throughout the universe. Gravitational fields, however small, subtly bend light, making the universe a gigantic, intricate system of optical illusions and warped paths. We often refer to the cosmic microwave background as a static background, but the lie is its unchanging nature. The CMB photons have been traveling for 13.8 billion years, constantly stretching and cooling as the universe expands. In the past, it was much hotter and brighter. In the distant future, it will be so stretched and cooled that it will become nearly undetectable. It's a dynamic fossil, constantly evolving, much like the universe it reflects. The concept of the observable universe creates an impression that there's a literal edge, or wall, beyond which nothing exists. This is a profound lie of perception. The boundary is a light horizon, defined by how far light has had time to travel to us since the Big Bang. Beyond that horizon lies more universe, perhaps identical in its properties, perhaps different. It's simply space from which light hasn't reached us yet. There is no physical barrier, just a limit to our current information. While general theories explain how galaxies form from collapsing gas and dark matter halos, the specifics remain complex. How do spiral arms persist? How do supermassive black holes grow in exact proportion to their host galaxies? Why are some galaxies so distinctively shaped? The lie is the impression of a complete, settled understanding. Galactic formation is a chaotic dance of gravity, gas dynamics, dark matter interactions, and stellar feedback, still fraught with active research questions and unresolved puzzles. We commonly perceive the sun as yellow, sometimes rendering it with a distinct yellow circle. This is a cultural and atmospheric lie. The sun, when viewed from space or through instruments filtering out atmospheric effects, is actually white. It emits light across almost the entire visible spectrum, and our atmosphere scatters blue light more efficiently, making the sun appear yellow from Earth's surface, especially at dawn or dusk. Its true hue is a brilliant, pure white. Cosmic rays, high-energy particles bombarding Earth from space, are a constant cosmic presence. While we know many originate from supernovae, active galactic nuclei, or neutron stars, the highest energy ultra-high energy cosmic rays defy simple explanation. Their origins are elusive due to magnetic fields deflecting them. The lie is our complete understanding. These incredibly powerful particles present a cosmic mystery, potentially signaling unknown astrophysical processes, or even new physics at play in the most extreme corners of the universe. The universe is permeated by neutrinos, often called ghost particles because they rarely interact with matter. Trillions pass through your body every second, completely unnoticed. While massless in early theories, we now know they have tiny masses, a crucial discovery. The lie is their undetectability. Massive detectors deep underground or in ice can capture their elusive signatures, revealing a universe far more populated by invisible, interacting particles than our senses or simple models indicate. Ultimately, the greatest deception about space stems from our own biological limitations. We perceive a tiny sliver of the electromagnetic spectrum, hear a narrow range of frequencies, and experience time and gravity in ways fundamentally different from their true cosmic nature. The lie is that our inherent senses are capable of grasping the universe's full, multi-dimensional, multi-frequency reality. Only through scientific instruments, mathematics, and profound imagination can we begin to transcend these biological constraints and peer beyond the illusions. We often perceive the universe as a grand, static backdrop against which events unfold. This is a profound lie. From the smallest quantum fluctuations to the largest cosmic structures, the universe is in constant motion, evolving, and dynamic. Stars are born and die, galaxies merge, clusters form, and space itself expands. Nothing is truly static, revealing a vibrant, active cosmos that is perpetually recreating itself, far from a tranquil, unchanging tableau. Many popular accounts of the Big Bang describe a singularity, a point of infinite density and temperature. This is a theoretical extrapolation, a mathematical lie that arises from general relativity breaking down under such extreme conditions. Most modern cosmological models, particularly those involving quantum gravity, suggest that the universe did not begin from an actual singularity, but rather from an incredibly dense, hot, yet finite state. What truly existed at that primeval moment remains a frontier of physics. Our astronomical textbooks list stars, planets, galaxies, black holes. But the lie is that the list is complete. Astronomers are regularly discovering entirely new classes of celestial objects, fuzzy objects that are too big to be planets but too small to be stars, ultra-diffuse galaxies almost invisible to telescopes, or black holes of intermediate mass. The universe continues to surprise us with its inventiveness, proving that our classifications are merely snapshots of an ever-unfolding cosmic reality. We typically define the universe by its matter and energy content. But the lie is the exclusion of information. Theories like the it from bit principle suggest that information itself might be a fundamental component of reality, just as crucial as matter and energy. The universe could be viewed as a giant cosmic computer or a holographic projection, where information dictates its very structure and evolution. This radical concept redefines existence, making information not just a description, but a fundamental building block of the cosmos.